Okay, we start with learning outcomes 6.2e, define first ionization energy. So what is meant by ionization energy? Ionization energy is the minimum energy required to remove an electron from the ground state of the isolated gaseous atom or ion, which means ionization in energy is used to remove the valence electron. Alright, so what is meant by first ionization energy? Okay, so first ionization energy is the minimum energy required to remove 1 mole of electron from 1 mole of neutral gaseous atom in its ground state. So we can describe the definition based on the equation. Okay, so it shows that the first ionization energy, which means the first electron, the energy needed to remove the first electron from the atom. So it takes positive 738 kilojoule per mole. So ionization energy is used when the atom, okay, wants to remove the valence electron from the outermost shell. Okay, so please take notes. The magnitude of ionization energy depends on the strength of attractive force between the nucleus and the outermost electron. So which means the stronger attraction from the nucleus to the valence electron, so the more energy needed to remove that electron. So the lower of ionization energy, the easier it is to remove electron from an atom and form a cation. Okay, so usually it is easier to remove the electron from the larger ion compared than the smaller ion. Okay, because the size is relates to the attraction from the nucleus to the valence electron. The process is endothermic, therefore energy must be supplied to remove the electron. Okay, next we go to the explain the variation in the first ionization energy across the period 2 and 3, and also when we're going down group 1 to 13 to 18. Okay, so it depends on the several factors. The first factor is atomic size. Of course, the smaller the size of atom, the higher the ionization energy will be used to remove the valence electron. But meanwhile, the valence electron of an atom with larger radius will be experience a less attraction towards nucleus, therefore possess a low ionization energy. So the larger the size of atom, less energy of ionization energy that used to remove the valence electron. The second factor is the effective nuclear charge. So when the higher the effective nuclear charge, the higher the ionization energy. So what is the relation of the effective nuclear charge with the ionization energy? So we know that effective nuclear charge are related to the size of atom. So the higher the effective nuclear charge, the smaller the size of the atom. Okay, the higher the nuclear charge, the stronger the attraction between the nucleus and electrons. Therefore, ionization energy increase. Okay, and then shielding effect or screening effect. Okay, shielding effect, when shielding effect increase, ionization energy decrease. So it is because the shielding effect of the inner electron cause the outer electrons to be less attracted to the nucleus. So therefore, the magnitude of ionization energy will be decreased. Okay, another factors is the stability of orbital, partially filled, half filled, or full filled. Okay, so partially filled orbital is less stable, so it makes the ionization energy lower. Half filled and full filled orbital is more stable than partially filled, therefore the ionization energy could be higher. The variation of the first ionization energy is divided into two, when we across period and when we going down a group. Okay, so when we can say that when we across period, ionization energy increase. So when we going down a group, ionization energy decrease. So remember that. Okay, next we go to the explanation when we across the period. So when we across the period, proton number increase, effective nuclear charge increase. So therefore the interaction between nucleus and the valence electrons getting stronger. So it makes the size of atom getting smaller. So it will be difficult to remove the valence electron. Therefore, the first ionization energy increase. Okay, next we go to the when we're going down a group. When we're going down a group, okay, number of shell increases, shielding effect increase. Therefore, the attraction from the nucleus towards valence electrons becomes weaker. Therefore, the size of atoms becomes bigger. It will easy to remove the valence electron. Therefore, the first ionization energy decrease. So, the factor that we discussed when we across period and the down the group is different. Okay, when we across period, the factor that we discuss is effective nuclear charge. But when we going down the group, the factor that we discuss is the shielding effect. Okay,